Hi. For today, we are going to discuss another statistical tools for multivariate analysis in line with our discussion of data analytics. Allow me to share my PowerPoint presentation. Okay, so we'll discuss the topics of discriminant analysis and logistic regression. So for today, I'll be teaching you how to or when to use these tools and what are some of their assumptions, okay, prior to using them. So I'll be giving you some insights, okay, on when to use these statistical tools. Recall that in real world, we are faced with choices. Like, for example, in this image, of course, we know that this could entail buying or not buying, okay, a certain product. So there are two options there, to buy or not to buy. The other one, to enroll or not to enroll. That's another one. Or perhaps you'll be faced with a scenario where you have to identify whether you are healthy or not healthy, or you have a good mental health or bad mental health. So it's the other way around. Or in real world, we are also faced, like in politics, for example, it's either to win or not to win, or will you be winning in this coming election, or will you be losing this coming election? So these are some of the things we want to predict. And it inspires us somehow to use some statistical tools and data, of course, combined to identify or to predict something. Okay. Or in other in many cases also, we are faced with not just two options but three or more. Like, for example, will you buy a large, medium, small popcorn, or not just in this example, but a lot of real world scenarios where you will be facing a lot of choices. Okay. So my point is that the regular regression analysis, of course, we were done with our discussion with multiple linear regression analysis. It does not apply to every problem or situation, especially in predictive or modeling technique. What we just understood about multiple linear regression is that um, the dependent variables are not I mean the predictive variables there are numeric, okay, and somehow um either continuous or discrete. So employ discriminant analysis and logistic regression when the dependent variable is categorical or nominal or non-metric in nature. So, and the independent variables at the same time are metric variables. So in this case, in this scenario, it's hard for us to use multiple linear regression analysis here because the dependent variable is categorical already. So what are these categorical variables? Okay. Now we know that the variables could be categorical or numerical. Okay. When we say numerical, it could be discrete or continuous. That's what I told you before. And in categorical, it could be nominal or ordinal. Examples of nominal variables are marital status, political party, eye color. These are defined categories. Somehow, the ordinal variables also are ordered categories like good, better, best, low, medium, high. So your dependent variables in discriminant analysis, okay, could be nominal or ordinal. But in logistic regression, since it's only binary, so most probably you will be facing with only two categories. Okay, so these are examples of nominal and ordinal variables associated with the categorical or under the categorical variable. So I'll give you a scenario here, okay, for discriminant analysis. No, so when there are there are two groups of dependent variables, especially like high or low, this is what you call two-group discriminant analysis. But when you have, for example, small, medium, and large, okay, these are the dependent. For example, the value or the associated categories for the dependent variable is it consists of small, medium, and large. Then that is multiple discriminant analysis because it's more than three already. Three or more, it's called multiple discriminant analysis. But when we have only two, okay, it's called two-group discriminant analysis. So it's just the same principles or concepts in analysis for discriminant analysis, whether it's two-group discriminant or multiple discriminant. So I'll provide you further illustration here. So suppose you have here groups based on purchase intention. So you want to predict if the respondents, okay, in this example, in this scenario, what you're going to predict is whether, you want to predict or you want to come up with understanding what essentially are the best predictors for the purchase behavior or purchase intention of the respondents. So we have, for example, 10 respondents here or 10 subjects. 5, okay, would purchase and another 5 respondents would not purchase. That's group 2. No, we have group 1, those would not purchase, and group 2, those would not purchase. Group 1, those would purchase, and group 2, those would not purchase. So the predictors here or the independent variables are durability, level of performance, and level of style or style. So we have x sub 1, x sub 2, and x sub 3 here. And of course, our y here, the dependent variable, would be consisting of binary number, the would purchase and would not purchase. And when you try to use an SPSS, you would place a value of 0 for would not purchase and 1 for would purchase, and that's for your value of y. It's either 0 or 1. Okay, so subject 1, okay, since the subject 1 would purchase, okay, its response or the response of subject 1 for durability is 8, performance 9, and style 6, and so on and so forth. And if you would notice, the group mean for group 1 is 7.4 for durability. For performance, it's 6.8, and for style, it's 4.0. And for group mean, it's 3.2 for would not purchase, group 2. For performance, it's 4.4, and for style, it's 3.8. Now, it's important to know this mean because later in the analysis, okay, of the discriminant analysis, especially in the analysis of your results, okay, it's important to consider also this means because you will be we will be identifying in the first phase, we will be identifying which of these factors or like durability, performance, and style would be used in our final model. Okay. So the assumption of discriminant analysis, just like any other statistical tools, I'm telling you that you cannot use one statistical tool for every problem because every statistical tool has an assumption. Especially in discriminant analysis, the assumption here is to meet multivariate normality of the independent variables and unknown but equal dispersion and covariance structure of matrices for the groups as defined by the dependent variable. However, if these assumptions are not met, you may proceed with logistic regression or logit analysis, especially for binary dependent variable. Now, the only limitation here in logistic regression is that you are just confined with only binary variable, like the yes or no, 0 and 1, only values. Unlike with discriminant analysis, okay, it could use 0 or 1 or more, like low, medium, small, medium, large. Okay, like for example, 1, 2, 3, or 0, 1, 2. Yeah, so more than that. No? So that's the beauty of discriminant analysis. However, it's just very strict. The only The only the disadvantage somehow is that it's very strict with the multivariate normality of the independent variables. Okay, and that's our discriminant analysis, but not so with logistic regression. However, in logistic regression, you only have two binary dependent variable here. Okay, I mean, yeah, you have a binary dependent variable. I mean, the values should only range from 0 to 1, or 1, 2, or but for as long as it's binary. Okay, so for interpretation of results of discriminant functions, so this is the link. Okay, I'm giving you, and you may read this one. Of course, I'll be providing you um another video, okay, for the interpretation of the results of discriminant analysis, and especially an illustration, not a lecture on how to use SPSS, um, with discriminant analysis. And let's proceed to logistic regression or logit analysis. So discriminant analysis is appropriate, as I've told earlier, when the dependent variable is non-metric. It's the same thing here with logistic analysis, logistic regression. However, when the dependent variable has only two groups, logistic regression may be preferred. Okay, like for example, I told you earlier, 0 will stand for example, will not buy, and 1 will stand for will buy. So that's why it's called binary. So that could be your dependent variable, okay? And you are interested to finding out here, okay, uh, what factors would, trigger someone to buy or not buy a certain product, okay? So that's logistic regression, or we call it logit analysis. Discriminant analysis is strict in meeting assumptions as I've told you earlier. It's strict in meeting assumptions of multivariate normality. But logistic regression does not face these strict assumptions. Many researchers prefer logistic regression because it is similar to multiple regression. It has straightforward statistical tests, similar approaches to incorporating metric and non-metric variables and nonlinear effects, and a wide range of diagnosis. So this is the difference between linear regression and logistic regression. So you cannot use linear regression when your data, especially for your binary dependent variable, we only have two values, 0 and 1, for example. So it's hard for you to use linear regression, and it does not qualify. Okay, the data doesn't qualify for linear regression for that matter, but for logistic regression, it qualifies. So that's why we have this two different graphs here, because we will be understanding the add ratio. Okay, uh, unlike linear regression, we know how it can be interpreted. Also, there's another. Um, um, it also has a separate way of interpretation of results in logistic regression. Uh, so logistic regression model, suppose we have three variables here, and you want to identify what makes someone happy or sad. So you have three chosen factors or independent variables here, x sub 1, x sub 2, and x sub 3. Okay, which of these factors are predictive, or would predict someone to be happy or sad? So that's it. That's our output. It's happy or sad. Okay. So logistic regression is just as simple as that. Okay, it's just like linear regression model. However, we only have binary values, or we have the values for the dependent variable are binary. So for the interpretation of logistic regression results, you can read this article. Okay, I'll be providing you also this article. And when a binary outcome variable is modeled using logistic regression, it is assumed that the logit transformation of the outcome variable has a linear relationship with the predictor variable. So take note of that. So interpret the add ratios in logistic regression. That's how you interpret here. Now, in linear regression, it's easy to interpret using coefficients, how the coefficients, if you increase the value for your uh, example, for your independent variables, okay, what would be the contribution of it to to your dependent variable in response to the influence of your coefficients. So that's how you interpret it in simple or in simple or either multiple linear regression, but it's different here because you will be use the concept of odds ratio. So you can read it, that concept here in that article. I'll be providing you also a video, okay, showcasing how to do or how to perform logistic regression analysis in SPSS, and at the same time how to interpret the results thereafter. So for now, I'm just showing you a basic understanding, the foundation for you to understand the difference between logistic regression and discriminant analysis. In discriminant analysis, you have more than two values for your, or it's not binary because in logistic regression, it's binary for your dependent variable. But in your discriminant analysis, it can perform either binary or more. Like if you have choices for small, medium, large, okay, you can use discriminant analysis. But for logistic regression, it's binary, so you can only have 0 or 1 value here because it's binary. So in real world, yeah, as I've told you, we are faced with understanding certain responses, okay? And what affects or what are the factors that affect these responses. So these tools here, the logistic regression and the discriminant analysis are very useful, okay, if you are faced with that kind of problem. So that's all. Thank you very much.